Hello everybody, my name is Edwin R. I'm going to present you the talk entitled Repeatability of Distress Signals in Hornet Bees Beetles on Odontotaenius disjunctus. It was a result of a collaboration with Dr. Rafael Rodríguez and Dr. Gerlinde Höbel. Passalids are a family of beetles who live in the kind logs. They feed on decomposition wood and are characterized by their social habits, which include biparental care and the capacity to produce sounds in immature stages and adults. Sounds are produced by morphological modification. In larvae with the third and the second pair of legs, and in adults with the hind wings and abdomen. Sounds are produced in different behavioral contexts, such as reproduction, aggression, with conspecific when they are alone and when beetles are under distress. Indeed, Buchler and collaborators proposed that distress sounds are an antipredatory mechanism. They muted beetles by removing their hind wings and found that muted beetles were eaten faster by crows. Several authors proposed that the function of antipredatory mechanisms could be scare predators, as Buchler said, attracting natural enemies of predators, and alerting or requesting help from conspecific. In particular, this function needs that the behavior must be repeatable, at least at individual level. The objectives of this work were determine if distress sounds are individually repeatable and evaluate which intrinsic or extrinsic characteristics may affect the distress sounds in Odontotaenius disjunctus. For doing that, we recorded 21 specimens of Odontotaenius disjunctus, all of them collected in Memphis, Tennessee, 7 males and 14 females. We recorded each specimen during 3 days, each day with at least 3 attempts. 3 attempts in the first day, 5 in the second, and 5 in the third. Each attempt was a recording of 5 seconds. For induced sounds, we touched slightly the beetle head. Then, in another day, we measured the maximum amplitude from 3 body sides: front, behind, and lateral side. The variable was measured with a speedometer 5 times per individual. Recordings were analyzed using Audacity. We selected the chirp with maximum amplitude peak to peak as a landmark chirp. And then we measured chirp duration, dominant frequency, and chirp rate during 5 seconds. As independent variables, we used temperature, recording day, attempt, sex, mass, body size, and muscle weight. To calculate the last one, we followed the methodology proposed by Villada Bedoya. Muscle weight was a difference between dry weight before and after putting the specimens into a solution of potassium. Statistical analyses were performed using R software. We performed linear mixed effect model for each sound attribute using the independent variables listed previously: sex, temperature, and the interaction between sex with day, attempt, mass, size, and muscle. And we use as a random effect the individual ID. Then we separate the dataset according to their sex and calculate with another linear mixed effect models the repeatability of each attribute by sex. To calculate the repeatability, we follow the equation proposed by Nakagawa. They say that the repeatability is a proportion of the percentage of variance explained by the random factor, in this case the individual ID, and the total variance. As a result, we found that the chirp duration fluctuated across the recording days without a tendency, as well as the chirp rate in females. Whereas in males, the chirp rate increased with the recording day. Maybe males are more aggressive, but it is necessary to prove it. And regarding to the attempt, the chirp rate increased after the second day, and then maintain constant. Regarding to the dominant frequency, the frequency was inversely related with the mass and with muscle. The same pattern was found in other groups of animals, like insects and vertebrates. Frequency also changed with interaction between temperature and sex. In males, the dominant frequency increased and the temperature increased too. This pattern was found in other groups like fishes. On the other hand, amplitude decreased with temperature in frontal and lateral sides. Finally, chirp duration, rate, and amplitude measured from behind side are repeatable at the individual level. The observed repeatability was significant in both sexes, and the repeatabilities were consistent with reports of other antipredatory behaviors. This finding demonstrates that discrete sounds are not produced randomly, and this kind of sounds may have an important role in the familiar groups of passalids. Thank you for your attention. Any question?